Okay, you're welcome. If you can hear me, can you just indicate? If you can hear me, indicate in the chat box below. Just say I can hear you. If you can hear me, say you can hear me. Okay, okay. All right. Okay, good one. So quickly would be going into the exam focus for SLT 210 210.1, and the course of course is titled Woodwork. Okay, Woodwork sometimes is stemmed carpentry technology or woodwork technology. All right, so we'll be treating some exam focused questions. All right, some exam focused questions based on the course. All right, so I'll just like you to just take note of these questions. All right, just take note of these questions. So when I give the questions, I'll also give the answers to it. All right. Okay, so let's dive into it quickly. So question number one says dash and dash are the basic categorical classification of woods. Dash and dash are the basic categorical classification of woods. So it's basically a question that focuses on the types of wood. All right, types of wood. What are the classes of wood, basically? Okay, so wood is classified into hardwood and softwood. All right, so that's it basically. All right, so that's number one question. All right, then number two question: dash are generally denser and stronger and are mostly used in furniture and flooring. Dash are generally denser and stronger and are mostly used in furniture and flooring. Okay, are mostly used in furniture and flooring. So what's the answer to that? So the answer to that is hardwoods. All right, so hardwoods are generally known to be denser, have higher density, and they're also stronger. Like hardwoods have stronger material, and they are commonly used in the production or design of furniture and also for flooring. All right, some some places in advanced countries, or maybe not necessarily advanced countries, even in Nigeria here. Okay, there are places where they actually use wood for flooring. All right, wood for flooring, not necessarily the whole tiling and all of that. Sometimes they use wood to replace floorings. All right, so that's that. Okay, so the next question. All right, the next question: dash are also referred to as being deciduous in nature. Dash are also referred to as being deciduous. Deciduous is spelled Decidous. Okay, Dous, deciduous. Okay, so what are the materials that what are the things that are also known to be deciduous in nature? So the answer is hardwoods. So hardwoods are known to be deciduous in nature. All right, the next question, dash dash and dash are examples of examples of hardwoods. Dash and dash are examples of hardwoods. A A oak tree and conifers. Oak tree and conifers. B Iroko tree and salamander tree. C Iroko tree, and moringa. D, all of the above. So this particular question is an option question, lettered A to D. All right. So of course the correct option is Iroko tree and moringa. Those other ones that were actually mixed up. The oak tree is actually correct. Oak tree is a hardwood, but the one that we did, salamander tree and all of that, they are not. It's not actually a hardwood. All right. There was also one that talks about conifers. It's not actually a hardwood as well. All right. So the examples of hardwoods there are Iroko tree and of course moringa. All right. So moringa is also an example of a hardwood. All right. So next question. Next question. That shall refer to as needle-like materials. Okay, that shall refer to as needle-like materials known to be evergreen. That shall refer to as needle-like materials known to be evergreen. Okay, so the answer to that is softwoods. So it's actually softwoods that are known to have a needle-like shape and also to be evergreen. All right. Okay, so the next question, one of the following is a synonymous name used to characterize softwoods. One of the following is a synonymous name used to characterize softwoods. Number one, that's A, option A, deciduous. Option B, conspicuous. Option C, coniferous. Option D, none of the above. All right, none of the above. So the answer, of course, is coniferous. Okay, so it's a characteristic of softwood. So that's why softwoods are also called conifers. All right, so that's why softwoods, they're also called conifers. Okay, so the next question, I believe we are together, right? Okay, and one other thing we need to know about softwoods is that unlike hardwoods, softwoods tends to actually grow faster. All right, the growth of softwood is actually rapid when compared to hardwood. All right, so they grow faster. So it's important for you to note that. All right. Okay. So the next question. Okay. All right. So dash are basically known to be heterogeneous in nature. Dash are basically known to be heterogeneous in nature. So the answer is wood. All right. So wood is heterogeneous. It's not homogeneous. It's heterogeneous because when you say homo has to do with one kind. Wood is not of one kind. Wood is of different kinds. So when we say heterogeneous, we're talking about of different kinds, different origin. All right, different type, different material, different makeup. All right. So the answer is wood. Okay. So basically, this is as a result of the difference in species, like I said, difference in the species of woods. All right. So one thing we need to understand as well is that when it comes to woods, they are biologically different. There's a variability in their biological makeup. All right, you see one would have a totally different species from the other. All right, totally different species from the other. Okay, so the next question. Okay, next question. Now, all right, in wood setup, listen to me, listen to this question. In wood setup, dash is involved in the assembling and fastening of joints. All right, in wood setup, dash is involved in the assembling and fastening of joints. All right, so the answer to that question is proper fabrication. All right, so it's actually a characteristic of implementing wood, that is implementation of wood. All right. So when it comes to implementing wood implementation, we have to consider not just proper fabrication, we have to also consider a good design. Okay, we have to consider the fact that the choice of the wood matters a lot. All right, so it comes down to the scientific argument, asking yourself questions like what is, where, and when the wood will be used. What is the wood? Where would the wood be used? And when will the wood be used? So you don't just you don't just talk about the wood and all of that. All right. Some of you are saying you can't see, but you can hear. Right? Just listen. Just listen. All right, just listen. I don't want you to be distracted, so I believe it's best, okay, that you just listen. I turned off the video, so just listen, okay. All right, so I want you to actually pay attention. It's not a video class, so it's not a video class. All right, it's a live audio class. The video is turned off. I turned off the video. All right, so just pay attention. The video is not relevant now. What's relevant is what you're hearing. Is that clear? All right, so let's proceed. So okay, so what I was saying is that the choice of the wood matters a lot. All right, so you have to ask questions like what is the wood being used for? Okay, you have to ask where would the wood be used and when the wood will be used, because all of these things matters a lot. All right, because if you use a wood for a purpose that is not designed for that wood, then the wood may not serve the actual purpose that it was designed for. So what are we saying? You have to like pick a wood. You have to make the choice of a wood which would serve the specific purpose that it was designed for. Okay, and another thing is that you must also know where the wood will be used. All right, you must know when the wood will be used as well. Duration matters a lot. Okay, because if you consider when a particular wood would be used, you should also consider the fact that climatic and weather conditions affect the implementation of woods or usage of woods. All right, if you're trying to install a particular wood or use a particular wood during the raining season, there's a tendency that the rain drops and the rainy weather may affect the durability of that wood. Right, so it's important to note that. All right, so now another thing is another question here is dash are terminologies which are used to describe a strong wood. Dash and dash are terminologies used to describe a strong wood. All right, so so when we say terminology, we're talking about terms, we're talking about words, all right, which describes the strength of a wood. All right, so those terms are called stress and strain. So those are two common terminologies that are used to actually describe the strength of a wood. All right, so okay, so another question. Dash is defined as the ability to resist applied stress. Dash is defined as the ability to resist applied stress. All right, so the answer is strength. Okay, so strength is defined as the ability to resist applied stress. So when a wood can actually resist stress that is applied on it to an extent, it means that it's stronger. All right, so if you want to compare the strength of two different woods, the one which can resist more application of stress is stronger than the one that can not resist more, that can resist less. All right, so that's strength. Okay, so basically okay, another question. Now dash is a change in the normal structure of a wood or material. Dash is the change in the normal structure of a wood or material. Okay, so that is called strain. So strain is the change in the normal structure of a wood or material. Okay, all right. Now, okay, so the product of strain and the length of a material is referred to as dash. The product of strain and the length of a material is referred to as dash. So the answer is deformation. So how can you calculate the deformation of a material? You multiply the strain of the material by its length. So the product of the strain and the length is deformation. Basically, strain is the ratio of deformation and length. All right. So basically, if you have a question where you have to calculate strain, just divide the deformation by the length. All right, and you get the strain. All right. So that's a formula that you need to remember. All right. So it's important you note that. Okay. So moving forward. All right. The next question. Dash is referred to as a unit deformation. Dash is referred to as a unit deformation of a wood or material. The answer is still strain. All right, so it's still another definition for strain. Remember, I told you that a change in the normal structure of a wood or material is known as strain. All right, so that's still another definition of strain. Okay, so that's it basically. Now, all right, so okay, the next question. I believe we are together, right? We are still together. You can hear me, right? So if you can hear me, just say I can hear you, sir. All right. So I can see responses here. Okay. All right. So moving forward, I'll also continue with some questions as well. All right. So okay. All right. So name three main cell types in wood. All right. Three main cell types in wood. So what are the types of cells in a wood? Cell types in wood. All right. So the examples are, or the three main cell types are fibers, tracheids, and parenchyma. Okay. Fibers, tracheids. Tracheids is spelled Tracheids. Okay. Tracheids. Parenchyma is Parenchyma. Then of course fibers. All right. Okay. So next question: how are hardwoods different from softwoods? How are hardwoods different from softwoods? Okay. That is based on the following options. I'm going to be listing. All right. Now, first of all, hardwoods are coniferous and softwoods are deciduous. Okay, that's the first one. Hardwoods are coniferous and softwoods are deciduous. Okay, that's A. Then B, hardwoods are seasonal, while softwoods are prevalent. Okay, hardwoods are seasonal while softwoods are prevalent. Then C, hardwoods are from angiosperms while softwoods are from gymnosperms. Hardwoods are from angiosperms while softwoods are from gymnosperms. Okay, so that's C. Then D, none of the above. All right, so the first one talks about hardwoods being coniferous and softwoods being deciduous. All right, so hardwoods cannot be coniferous. It's the other way around. All right, it's the other way around. All right, so hardwoods are actually deciduous, while softwoods are the coniferous ones. All right, but the C actually correlates with the correct option. All right, I don't know if you are told that hardwoods are actually gotten from angiosperms, while softwoods are gotten from gymnosperms. So it's one thing you need to actually take note of. So those are their sources. All right, those are their sources. Okay. All right. So then the next question. Next question. All right. So number okay, the next question. What is the function of tracheids? What is the function of tracheids? Remember I mentioned that we have fibers, tracheids, and parenchymas, the main cell types in wood. Okay, so what's the function of tracheids? So tracheids actually conduct water in softwoods. So they are conductors of water supply in softwoods. Okay, so that's the function of tracheids. That's the function of tracheids. So don't forget that. All right. So moving forward, we'll still continue by looking at some more questions. Still continue by looking at some more questions. All right, so the next question here is define juvenile wood. Okay, define juvenile wood. Okay, so juvenile wood is actually defined as a wood formed near early growth of woods which are less dense and has lower strength. Okay, so they are less dense and have lower strength. So juvenile wood is actually an example of softwoods. They are almost like softwoods. All right, they're almost like softwoods. Okay, so it's important to take note of that. All right, so moving forward. Okay, someone is asking if it's subjective or theory. Okay, the thing is this. For the past years, when it comes to SLT courses tends to be more subjective. All right, SLT courses tends to be more of subjective. So you can expect subjectives. Not like I'm saying that you should bank on subjectives, but expect subjective because that's the most common way SLT exams are usually set. All right. Okay. So moving forward. Okay. All right. So the next question here is dash is the measure of the rate of heat flow through materials subjected to nature gradient. All right, nature gradient or temperature gradient particularly. All right, so dash is the measure of the rate of heat flow through materials subjected to temperature gradient. Okay, so the answer to that is thermal conductivity. All right, thermal conductivity. Okay, so someone is asking that are juvenile woods examples of softwoods or they are like softwoods? Okay, the thing is that they are like softwoods. We cannot clearly categorize them as softwoods because they do not have all the characteristics of softwoods, but they have most of the characteristics. Softwoods are less dense. Softwoods are softer. All right, in nature. Softwoods also accumulate more water content. All right, so that's why sometimes we tend to categorize them as softwoods, but they are not an exact example of softwoods. They are like softwoods. All right, so okay, I should repeat what I said about juvenile wood. Someone said I should repeat what I said about juvenile woods. Okay, I'll repeat that. All right, so I said, okay, I said basically the question was what are juvenile woods? Okay, so I say juvenile woods are woods which are formed in early growth of woods which are less dense and has lower strength. Less dense and have lower strength. So they are formed in the early growth. They are not really mature in nature. All right, so we cannot really call them softwoods. Okay. All right. So now um moving forward, the next question is, I've talked about thermal conductivity. I say it's the measure of the rate of heat flow through materials that are subjected to temperature gradient. All right. So the next question. Okay, the next question. Thermal conductivity is basically measured based on dash temperature units. All right, so it's basically measured based. So what is the thermal conductivity basically measured based on? All right, so it is measured based. The answer is British thermal unit, BTU. All right, BTU. So that's the thermal unit for measuring thermal conductivity. I said British thermal unit. All right, BTU. Okay, BTU. All right, so the next question here, one of the following is not a factor in which thermal conductivity is dependent on. All right, so let me take that question again. One of the following is not a factor in which thermal conductivity is dependent on. All right, so we have A, longitudinal, B, transverse, C, moisture content, D, all of the above. I'll take it again. A, longitudinal, B, transverse, C, moisture content, and D, all of the above. All right, so basically that's it. So the answer is all of the above because basically when it comes to thermal conductivity depends on longitudes, okay, of heat flow. That is longitudinal heat flow. It also depends on transverse heat flow. It also depends on the content of the moisture in the wood. So that's also correct. So it means that all of the above is correct. All right. The specific gravity of the wood self is also something that's usually put into consideration. All right. So that's it. All right. That's it. Now the next question. All right. So I believe we are still together, right? All right. So now the next question. Dash is the ability of a wood to resist heat or conductivity. Dash is the ability of a wood to resist heat or conductivity. All right. So the answer to that is resistivity. So the resistivity of a wood makes it able to resist heat or conductivity. You know, water is actually present in wood. So because of the water content, we got moisture content. Not necessarily water, any form of moisture that is in the wood can make it to actually conduct electricity. All right. So when a wood has a certain level of resistivity, it can be able to resist heat or conductivity. All right. Heat or conductivity. All right. So it's important to actually note that. All right. So moving forward, the next question. Dash is the measure of the speed with which a material can absorb heat from its surroundings. I'll take it again. Dash is the measure of the speed with which a material can absorb heat from its surroundings. Someone is asking, is it thermal resistivity or just resistivity? Okay, in this context, we are talking about temperature. All right, talking about temperature and conductivity. So we can't just say thermal resistivity because we are talking about both heat and conductivity. So it's resistivity generally. If we are talking about only heat, then it's thermal resistivity. Thermal resistivity is the ability of the wood to resist heat. But thermal conductivity, all right, thermal conductivity has to do with, like I explained earlier, okay, has to do with the ability of the material to actually conduct electricity. So resistivity is not just thermal. Resistivity generally focuses on the ability to resist both heat and conductivity, or heat or conductivity. Either you say heat and or heat or. All right, so it's best to use resistivity, because if it is only heat that it is resisting, then it's safe to actually say it is thermal resistivity. All right, it's safe to actually say it's thermal resistivity if it is only heat that is resisting. All right, all right. So like I said, dash is the measure of the speed with which a material can absorb heat from its surrounding. All right, so the answer is thermal diffusivity. Thermal diffusivity. All right, so when it can be able, it's just like diffusion. Okay, just like diffusion. So when a material can actually absorb heat from its surrounding, it means that heat diffuses into the material. Okay, so that's what we call thermal diffusivity. Okay, all right, thermal diffusivity. Okay, moving forward. Okay, dash dash has a low thermal diffusivity because of its low thermal conductivity, okay, and moderate value for both density and specific heat. I'll take it again. Dash has a low thermal diffusivity because of its low thermal conductivity and moderate value for density and specific heat. So what is known to have a low thermal diffusivity because of the low thermal conductivity and moderate value for both density and specific heat that it has? It's actually wood. Wood has a low thermal diffusivity, which means that when we say low thermal diffusivity of a wood, which means that the measure of the speed at which the wood will absorb heat from its surrounding is low. So why is it low? Okay, it is low because it has a low thermal conductivity as well. Okay, it cannot conduct heat so highly. All right, its ability to conduct heat is low, it's not high. And the values for its density and specific heat is also moderate. So it's also moderate. Even when we say that hardwoods are more dense, doesn't mean that the density is so high. All right, that doesn't mean that the density is so high. We are just saying that it is more dense when you're comparing it to softwood. All right, but normally the density is at moderate level. All right, so that's one thing we need to understand. All right, so dash is the measure of the dimensional change, okay, of a wood. So the dimensional change of a wood is known as dash. All right, so the answer is thermal expansivity. All right, thermal expansivity, or also known as thermal expansion. All right, sometimes it's also referred to as coefficient of thermal expansion. So that dimensional change of a wood that is actually caused by the differences in temperature is what we call thermal expansivity. All right, so that's it basically. So don't forget that. All right, that thermal expansivity is the measure of the dimensional change of a wood. And why is this dimensional change of the wood prevalent? It's prevalent because of differences in temperature. All right, and it's called coefficient of thermal expansion. So it's important to take note of that. All right, all right. So next question, the ignition temperature of a wood is dash. Ignition temperature of a wood is dash. Okay, so the answer is 275 degrees Celsius. Okay, 275 degrees. So what does ignition temperature means? It means the ability of a wood, the temperature that a wood will actually attain before it ignites, more like before it burns. Okay, before it burns. All right. So it's a fire property. It's a fire property of wood. So that's ignition temperature. Don't forget, it's 275 degrees Celsius. All right. You see how high that temperature value is. We are not talking about Kelvin. We are talking about degrees Celsius. We're not talking about Kelvin. So that's it. So that's it. All right. So the next question. All right. Now dash is known not to combine directly with a wood substance at low temperature. Dash is known not to combine directly with a wood substance at low temperature. All right. So when a wood is at low temperature, what is that thing that is known not to combine with the wood? All right. So it's oxygen. So when oxygen has low temperature, it's actually difficult. Sorry, when a wood rather has low temperature, it's difficult for oxygen to combine with it. All right. So what we are saying in essence is that oxygen can actually combine with a wood when it's at high temperature. All right. So it's when it's at high temperature that the oxygen would be commonly present around that wood. Okay. So it's something you need to take note of. All right. Something you need to take note of. All right. So, okay, the next question. Now, list different factors which influences ignition rates. Okay, ignition rates through the accumulation of its heat. So what are the factors that influence the rate of ignition when heat has been accumulated on the surface of a wood? That's what the question is talking about. All right. So what are the factors that you say the wood are depended on when there is when there's excess heat on the surface, or when the thermal rate or thermal nature is actually high? So I'll be giving you about 3 of them. Number 1 is actually the rate at which heat has been lost, the rate of heat lost from the surface. Because for ignition to be possible, heat has to be lost from the surface. All right. So heat will now be lost to the surrounding from the surface of the wood. Another thing is also the size. The size of the wood also influences the rate of ignition. All right. Also influences the rate of ignition. All right. Then also remember that it will be at high temperature. So the amount of oxygen in the surrounding can also influence the rate of ignition. The amount of oxygen can also influence the rate of ignition. Remember, it has to be at high temperature before oxygen can actually combine with it. All right. So that's something that is important for you to understand as well. All right. So all right, moving forward. Next question here. The next question. One of the following is not a type of wood deterioration. One of the following is not a type of wood deterioration. When wood deteriorates, when wood loses its actual nature, when a wood is actually losing the properties that makes it a good wood. Okay, so what are the types? A, mechanical deterioration, or basically it's not like the types. The question is not talking about the types. The question is focusing on which of these types or which of these options is not a type of wood deterioration. All right. So I said A, mechanical deterioration, B, chemical deterioration, C, kinetic deterioration, and D, weather deterioration. All right. I'll take it again. A, mechanical deterioration, B, chemical deterioration, C, kinetic deterioration, and D, weather deterioration. All right. So basically, we have mechanical deterioration is actually a type of deterioration. All right. So that's correct. A is correct. Chemical deterioration is also correct as a type, but there's nothing like kinetic deterioration. There's also what we call weather deterioration. Weather deterioration is a form of environmental deterioration. All right. So also in this option, there's no biological deterioration. Biological deterioration is another type of deterioration. All right. Okay. All right. So now another question. Another question. Now dash is a form of deterioration responsible based on biotic factors. All right. So dash is a form of deterioration responsible based on biotic factors. So basically, which form of deterioration is as a result of biotic factors like life factors? All right. So basically, that type of deterioration is biological deterioration. All right. So it's biological deterioration that is based on biotic factors. So examples of biological deterioration, we have fungal decay. That is when the fungus decays, like mushroom, bread mold, which other one? Mushroom bread mold. Okay, yeast as well. Yeast is actually a form of biological deterioration when fungus decays. Yes, when fungus decays. All right. So insect decay, when insect decay as well, is a form of biological deterioration. All right. Let me just explain all the forms of deterioration. We have mechanical deterioration. Examples: when there are cracks in the wood, when there are splits in the wood, when woods twists, when there's twisting, okay, when the surface of the wood wears off. So that's mechanical. It's also a physical deterioration. All right. So examples of another one is chemical deterioration. Examples we have when moisture, for instance, when the wood is very dry, so moisture content deteriorates. All right. When some joints finishes actually experience corrosion, okay, that's also another form of chemical deterioration. All right. So someone is still asking if it's objective or subjective. I said you should expect subjective because of previous years. All right. Because of previous years, expect more subjective. I'm just adding a few objective into the past questions. I'm just adding a few. All right. So it's not like it's going to be OBJ. Expect more subjectives. All right. So that's it basically. All right. So the next question. The next question. Now wood dry. Keeping wood dry is critical for dash. It's critical for dash. All right. So when you keep wood dry, it's critical for moisture control. Okay. It helps in controlling moisture. Okay. So how do you even do that? You also try to ensure that the wood is ventilated. Use proper ventilation. Ensure that they are vapor barriers. So vapor from probably kitchen. Okay. So someone was asking what answer. So what the answer of the biotic factors? And I said now that biotic factors are actually fungal decay. Those are the biotic factors. Fungal decay, insect decay. All right, those are examples. All right, so take note of that. And biotic factors is actually what causes biological deterioration. All right, it's what causes biological deterioration. So I said keeping wood dry is critical for dash. So it's critical for moisture control. All right, so it's critical for moisture control, to control moisture in a wood. All right, okay. So next question. Next question. All right. Now the presence of insects or powdery substances is an indicator for dash. Okay. I'll repeat. The presence of insects or powdery substances is an indicator for dash. So the answer is that it's an indicator for um for wood deterioration. So it's an indicator for wood deterioration. Someone is still asking how many forms of deterioration do we have? I mentioned it a while ago. I told you that we have four major forms. All right. We have the biological, we have mechanical, we have chemical, and we have environmental. All right. So take note of that: biological, mechanical, chemical, and environmental. Okay. So that's it. So don't forget that. All right. So moving forward, I just talked about the fact that we have different types of deterioration. Okay, and we've also been able to look at the different types and also the examples. So I said that the presence of heat, insects, or powdery substances are indicators for dash, or is an indicator for dash, and I say it's an indicator for wood deterioration. But that is not the only indicator. Just in case you see other questions or maybe other things related to this, that's not the only indicator. When you see visible cracks or some holes, those holes are called rot pockets, all right, or splits. It's also an indication that wood is deteriorating. When you notice that a wood that was always strong is soft or has crumbling textures in some areas of the wood, then it also indicates that wood is deteriorating. Okay, so when you also notice a decoloration, a particular area is coloring a different way, uh-huh, it's coloring a different way, then it's also a form or an indication that wood is deteriorating. All right, so sometimes you tend to experience some strong harsh odor, okay, in the wood. It's also an indication that the wood is deteriorating. All right, so don't forget that. All right, so now another question. All right, now dash is any substance having the ability to hold two materials together by surface attachment. I'll take it again. Dash is any substance having the ability to hold two materials together by surface attachment. For the last time, dash is any substance having the ability to hold two materials together by surface attachment. All right, so the answer to that question is adhesives. All right, adhesives. So an adhesive is actually a substance that can hold two materials together. All right, and these two materials are held together on their surfaces. That's why it's called surface attachment. All right, so examples of these um, adhesives, we have glue, we have paste, even cement as well. All right, even cement as well is an adhesive. All right, so but commonly what is used as adhesives for woods? All right, what is commonly used as adhesive? Someone is asking again about deterioration. I said mechanical, chemical, biological, and I also talked about weather deterioration, which is also called environmental deterioration. Okay, all right, let's move forward now. Okay, now list five types of glue. List five types of glue. All right, so five types of glue. We have casein glue. Casein is CASEIN, casein glue. We have animal glue, we have vegetable glue, we have albumin glue, and we have synthetic resin glue. I'll take it again. We have casein glue. Casein is spelled CASEIN. All right. We have animal glue. We have vegetable glue. Okay. We have vegetable glue. We have vegetable glue. We have albumin glue. Okay. And we have synthetic resin glue. Okay, so those are types of glue. I told you that glue is an example of an adhesive. All right, glue is an example of an adhesive. So take note of that. All right. Okay. Now, all right. So that's it. Now, then the next question is: dash are chemical treatments applied to timber to protect it from decay, moisture, and withering. So I will take it again. Dash are chemical treatments applied to timber to prevent it from decay, moisture, and withering. Okay, someone is saying I should list the types of glue again. I said casein glue. Casein is CASEIN. Casein glue, animal glue, vegetable glue, albumin glue, and synthetic resin glue. Synthetic resin glue. All right, synthetic resin glue. All right, so moving forward, I say dash are chemical treatments applied to timber to protect it from decay, moisture, and withering. So the answer is wood preservatives. So when wood preservatives are actually applied to timber is a form of, is an example of wood. Okay, so when it is applied, when wood preservatives are applied, it would prevent it from the word preservatives, it prevents it from decay, prevents it from excessive moisture. Too much moisture in wood can actually damage the wood texture. All right, withering as well can actually damage wood texture. Okay, all right, so moving forward, okay, dash and dash are common types of wood preservatives. Okay, dash and dash are common types of wood preservatives. Number one, we have copper-based preservatives. Copper-based preservatives. All right, that's one type of preservatives. All right, so number two, okay, number two, we have still under copper-based preservatives. There are different examples of copper-based preservatives. We have the alkaline copper quaternary, which is denoted as ACQ. Alkaline copper quaternary. We have the copper azole. Azole is spelled AZOLE. Then we have the copper borate. Borate is spelled BORATE. All right, it's actually a form that has boron in it. Okay, copper borate. Okay, so like I said, basically we have the copper-based preservatives, the alkaline copper quaternary, which is an example. We have the copper azole, and we have the copper borate. Azole is spelled AZOLE. Okay, then we also have what we call the chromated copper arsenate. It's also a type of preservative. Okay, chromated copper arsenate. Arsenate is spelled ARSE. Okay, NATE. So that's called chromated copper arsenate. Then we have also the ammonical. Ammonical is spelled AMMONICAL. We have ammonical copper preservatives. All right, ammonical copper preservatives. Okay, there are many more. There are many more types of preservatives, wood preservatives. There are many more. All right, there are many more. Okay, so basically, we're looking at another question. So this is another question. Dash are finished systems applied to timber surfaces to shield them from moisture, UV light. Where is WARE? and biological attack, while also enhancing their appearance. Dash are finished systems applied to timber surfaces to shield them from moisture, UV light, wear, and biological attack. So what are those finished systems? They are called wood protective coatings. Wood protective coatings. So when wood protective coatings are actually applied to timber surfaces, these wood protective coatings helps to shield them from moisture, UV light. Remember, wood protective coatings and wood preservatives are not the same. All right, those ones, they are chemical substances. These ones are substances that are actually applied. All right. Someone is asking, oil preservatives, water preservatives, organic preservatives. There are also types. Yes, like I said, there are many. There are many types. Yes, okay. There are numerous types of preservatives. So if you add oil preservatives, water preservatives, and organic preservatives to the ammonical, to the copper based, okay, it's still fine. There are many, like I said. All right. So moving forward, like I said, these these finished systems, they are actually applied to timber surfaces. So they are coatings, okay? They are coatings that prevents them from experiencing any form of biological attack, and it also enhances their appearance. So it's these wood protective coatings that actually makes woods to look beautiful in appearance and all of that. All right, so that's it. Okay, so dash and dash are common types of coatings. Okay, number one type. I'll be giving you three types. Number one, we have transparent and natural look finishes. All right, all right. So transparent and natural look finishes. Okay, we also have the lacquers. The lacquer is spelled LACQUERS. It's also a common type. All right. We also have fluid and film forming sealers. Okay, fluid and film forming sealers. It's also an example of wood coating. We also have opaque and pigmented coatings. Opaque and pigmented coatings. It's also an example. All right. Let me give you another one. We also have water repellent and penetrating finishes. Water repellent and penetrating finishes, also called WRP. All right. They sometimes they even, aside being coatings, they can act as preservatives as well. All right, like I said earlier, based on what someone pointed out, water preservatives. So water preservatives are also coatings. All right, so they can also act as coatings as well. All right, so we also have some outdoor coatings. Okay, so I have some outdoor coatings. All right, so that's important to note. All right, so I think that's all. That's all for more like a summary of exam focus and preparatory questions for this course. Okay, so I want to say thank you for tuning in, and all the best in your exams tomorrow. I believe by God's grace we'll do more of this in subsequent courses. All right. So WRP, I say this water repellent preservatives. Someone is asking. I say water repellent preservatives. Okay. So like I said, it's a coating, and it also acts as a wood preservative as well. It plays double roles. All right. So that's what we would actually call it a night. Like I said, I will do more of this for subsequent courses. For those of you who are asking, I said, what you say, what about MDS? I said MDS, I already stated initially that MDS will be treated tomorrow. Okay, that's what I said. All right, so thank you for your time, and all the best in your exams.